Let's look at OpenStax College Physics, Chapter 13, Problem 19. A physicist makes a cup of instant coffee and notices that, as the coffee cools, its level drops 3 millimeters in the glass cup. Only a physicist would notice that. Show that this decrease cannot be due to thermal contraction by calculating the decrease in level if the 350 cubic meters of coffee is in a 7 centimeter diameter cup and decreases in temperature from 95 degrees Celsius to 45 degrees Celsius. Most of the drop in level is actually due to escaping bubbles of air. All right, so let's write down the things that we know. We know that the coffee drops in height by 3 millimeters. And the original volume of coffee was 350 cubic centimeters. The diameter of the cup D is 7 centimeters. And the temperature, the initial temperature was 95 degrees Celsius. And the final temperature was 45 degrees Celsius. So we want to check whether this is just volume contraction or if something else happens here. So we're going to check, double check the delta H. So we want to see if delta H is really 3.00 millimeters due to thermal contraction. All right, so let's figure out first what the original volume of coffee actually is. So we know that V naught is 350 cubic centimeters, but what is that in terms of the volume of the cup? So we know the volume of this kind of shape is going to be the area at the base times height. So this would be pi r squared times h. This is my r, and this would be the h. All right. Then delta V, the change in volume, will be pi r squared, those don't change, delta H. But by volume thermal expansion, we know that delta V is V naught beta delta T. Here we have to stop and think a little bit. It is not just the volume of the coffee that's changing, it's the volume of the glass that's changing as well. So they both start out with the same initial volume, but they undergo thermal expansion or thermal contraction at different rates based on their coefficient of volume expansion. So then I will have to write this as delta V is V naught, and we're subtracting B coffee minus B glass, because the glass changed shape as well, and that is in a time delta T. So now I can combine this equation with that equation. Both of them are delta V's, the same delta V, so I can set V naught beta coffee minus beta glass times delta T equal to pi r squared delta H. And we'll solve for the delta H. So that would be V naught beta coffee minus beta glass times delta T divided by pi r squared. I'm going to have to convert everything into meters or cubic meters in the case of the volume. So V naught then is 350 times 10 to the negative 6th cubic meters. Then from tables in books, we can find the coefficient of volume thermal expansion for both coffee, which is roughly the same as water, and glass, and get 2.1 times 10 to the negative 4 inverse Celsius minus 2.7 times 10 to the negative fifth inverse Celsius, times delta T, which is 50 degrees Celsius, divided by pi, and the radius is 3.5 centimeters. We know the diameter, so the radius will be 3.5 times 10 to the negative 2 meters, and I have to square this. When we plug all these numbers into our calculator, we end up with 8.32 times 10 to the negative fourth meters for the height difference. So this much is accounted for by the coffee cooling. And if we convert this into centimeters, it would be 8.32 times 10 to the negative second centimeters, which is a lot less than the 3 millimeters that we had before. I guess let's convert this to millimeters. So that would be 0.832 millimeters. And the problem said that the coffee dropped by 3 millimeters, which is quite a bit larger than what we only get from volume thermal expansion.